Right, your algebraic fractions prep. First thing, the drill. Okay, you've got a functions question here. First one is find f of 3. What does that mean? That means plug in 3 wherever we had x. So, f of 3 equals 3 plus 2 over 3 plus 3, which is 5 over 6. Second one, f of x equals 2. Well, if f of x equals 2, f of x also equals x plus 2 over x plus 3. Now this is really important that you realise a difference. F of 3 means we plug in x equals 3. F of x equals 2 means we change that for f of x. So now we have our function of x equals 2. We then rearrange that. I'm going to times by x plus 3. Times out the left hand side, 2x plus 6 equals x plus 2. I'm going to take away this x on this side and take away the 6 from this side. So I get 2x minus x equals 2 minus 6. So I get x equals minus 4. And now, inverse function. Okay. Inverse functions, first step, we write down y equals x plus 2, x plus 3. Now we must remember to swap y and x. We don't have to do it as beginning step, but that's where I do it. I think it's the easiest one to do it at. So, x equals y plus 2, y plus 3. Now we're going to times by y plus 3. Because we do not like having the fraction on the bottom there. And we're going to times out that bracket. Okay, we're trying to solve for y, so I want to get all the y terms on the same side. I'm going to take y away, and then I'm going to take 3x away. You could have done it the other way around. You could have taken xy and taken 2. It's just not the way I'm choosing to do it. It doesn't actually matter. xy minus y equals 2 minus 3x. Now, we've got all of the y terms on one side and all of the non-y terms on the other. We can factorise y out of this. This is an important step because we've now got it so that we could divide by x minus 1. And that will give us y on its own. Now, really importantly here, we're not actually done yet. We were asked to find inverse f of x, and we've got y equals. So you have to write this last line. The inverse of x equals 2 minus 3x, x minus 1. If you don't do that, you will lose marks. Okay. Next, we're going to combine some fractions. Now, this may seem fairly easy, but it's just to try and set us up for what we did before. So, first one, 1 over 4 plus 1 over 5. Okay, we have to make the denominators the same size. I'm going to times the left one by 5 and the right one by 4. So we're going to get 5 over 20 plus 4 over 20. That equals 9 over 20. Taking away, similar concept. First thing we do is rationalise the denominators. So we have 2/3 minus 1/4, and that equals times the left by 4, 8/12 times the right by 3, minus 3/12. Now, they've got the same bottoms now, so this denominator is the same, so now we can just do one minus the other. 8 minus 3 is 5, and that equals 5 over 12. Okay, so when you're adding or taking, you must remember to make the denominator the same. However, that's not the case when dividing. So, when we're dividing, it's nice and easy. All we have to do is do 4 times 3 and do 7 times 4. But I want to show you a quick trick. First thing we can actually do here, we have 4 over 7 times 3 over 4. Well, we could times it out and then factorise, but we can see that we're going to have a 4 on top and a 4 on the bottom, right? In fact, that would equal 3 times 4 over 7 times 4. Now top and bottom have a factor of 4 in it, which we can cancel. Okay, so actually that equals 3/7. Now normally I wouldn't have bothered doing this step. What I would have done is when I had 4/7 times 3/4, I would have at this point cancelled that and immediately just had 3/7. Okay, so that's how I would have done it. Doesn't matter if you do it this way, but you must remember to cancel down, and it's easier to cancel top and bottom earlier rather than later. Last part of this is divide. So when we divide, all we do is we flip the second one, this is a really important thing, with one we're dividing by, over. So we have 7/9 divided by 5/6. That's the same as 7/9 times 6/5. Now I can see that there's a factor of 3 top and bottom. So I'm going to divide by 3. 9 divided by 3 gives me 3. 6 divided by 3 gives me 2. I can't see any other factors. So that is 2 times 7, which is 14, over 3 times 5, which is 15. And that is our drill done. So now onto the main. 14x divided by 2. Now, a lot of you might just see that you can divide the 14 by 2 and get 7, but I just want to break this up for you. Factors of 14 are 2 times 7, and we've still got a times x, and that's over 2. So what we do each time is, in effect, we break it up into our factors on the top and on the bottom, and then we see what cancels. Okay. Now, for a question like this, it was not strictly necessary. You could have just done it. However, for the harder questions, it might make your life easier. So, for this one, I can see the top and bottom I've got a factor of 3 and x. So I could divide x top and bottom, get rid of that squared, divide 3 of that top and bottom, get rid of 2. Okay, but in case you want to see it again, that's 2 times 3 times x times x. That's all over 3 times x. So 3 cancels, x cancels, and that equals 2x. Part C is 2 times 3 times x times, I'm actually going to leave it in y squared, I quite like it like that form, 2 cubed times x cubed times y. Okay, 2 will cancel with one of those 2's. There's no 3's to cancel top and bottom. That x will cancel with one of those x's. That y will cancel with one of those. And so, on the top, we're left with 3y. On the bottom, we're left with 2 squared, which is 4x. Done. And again, you don't have to use this method of timesing them out. I don't bother normally, but if you're finding one hard, breaking them into their prime factors for the numbers and breaking them up into their individual different letters for the algebra can make your life a lot easier. Okay, this last one. So that is 2 times 3 squared times 5 t to the 4 p cubed x over 5 squared t squared p to the 7. 2's got nothing to cancel with, 3's got nothing to cancel with. That 5 will cancel with one of those 5's. T squared will cancel with 2 of those, bringing it down to 2. And the p to the 3 will cancel with 3 of those, bringing it down to 4. So that equals 2 times 3 squared, 2 times 9, which is 18. T squared x over 5 p to the 4. And there we are, that one's done. Moving on. So now, what we're doing, rather than just simplifying fractions, we're going to add them up. We've got to make sure at the end, though, they are left in their simplest form. So, our first one here, our denominators are 3 and 5. The only way we're going to bring 3 and 5 together is by timesing this one top and bottom by 3, and this one top and bottom by 5. So, that becomes 3x over 15 plus 10x over 15. Bottom's now the same, 3x plus 10x is 13x. And we're done. B. Okay, this time we have an over 2 and an over 5. Okay, so this one's going to have to be times by 5, this one's going to have to be times by 2. So we're going to have 5x plus 2 over 10 plus 2x minus 3 over 10. That's going to be 5x plus 10 plus 2x minus 6 all over 10, and that is 7x plus 4 over 10. Moving up. Here we have 1 over x and 1 over 3x. Now we have to go, okay, how do we make x and 3x the same? Well, we can times the x by 3. And that's all we have to do with that one. We have to times the left one by 3 top and bottom. So it'd be 3 over 3x plus 2 over 3x. And that's because it's already got an x. So the only factor it needs now is a 3. So you could have times it by 3x here, this one by x, but then you've had to cancel there. Makes your life a lot harder. Okay, bottoms are now the same. So 3 plus 2 is 5. 5 over 3x. D. Okay. Again, we need to make them the same. Now, we can't just add 1 top and bottom to the left-hand side here. Okay, what we need to do is times. The only thing we can times these by is we can times this one by x plus 1 and this by x. So this equals x plus 1 over x plus 1 minus x over x plus 1. So you can see that this term, top and bottom, has been times by x plus 1. This term, top and bottom, has been times by x. They have the same denominator, so we can bring them together now. So this is x plus 1 minus x over x plus 1. These two are going to cancel. So that's going to equal 1 over x plus 1. And you could have times that bottom out. Okay. That is adding up the fractions and then putting them in their simplest form. And on. So now we are solving. Okay, there are lots of different ways we can actually do this. Our end aim is to just get x. Okay, I'm going to do it by making the left hand side into a single fraction and then solving from there. So, single fraction, it's got a 3 and a 2 on it. Don't like that. So I'm going to make them both into sixths. So this is going to be 2x over 6 plus 3x over 6 equals 10. 3x plus 2x, they're all over 6, so that becomes 5x over 6 equals 10. I can divide both sides by 5. X over 6 equals 2. X equals 12. So the only real difference here is at the end I'm going to get x equals. Rather than just adding these two together, I've had to then solve this fraction equals a number. Moving on to part B. Well, part B is actually quite nice. They've both got the same denominator. So I can just add them together. 2 plus 4 is 6. So 6 over x equals 6. We don't like it being over x, so we're going to times both sides by x. 6 equals 6x. Now we divide both sides by 6. Nice and simple. Right, the extension. Well done if you got this far. So, for the extension, what we've got to do is we've got to change the words back into algebra. So I have brought a certain number of puzzles. I'm going to say the number of puzzles I brought is X. Okay? And I'm then told that I sell a third of them in the morning, a fifth in the evening, and I got 7 left. So a third of my puzzles is X over 3. And a fifth of my puzzles is X over 5. And I've got 7 left. And that equals my total number of puzzles that I have. Does that make sense? Let's just go through that again. I sold a third of the puzzles I brought with me in the morning. If I had X puzzles, I've sold X over 3. Then I sold a fifth of them in the afternoon, X over 5. Now, if my total number is X, then this number in the morning plus this number in the afternoon plus 7 must equal X. So my aim is to get X equals. Okay? Now, again, a couple of ways that we can move around this. What I'm going to do is I'm going to move these two terms onto that side so I can have just numbers on this side and X is on this side. So I'll have 7 equals X minus X over 5 minus X over 3. Now, on my right-hand side here, I need to make them all have the same denominator, which is going to be 15 in this case. So I'm going to times them all up so they go over 15. This X is X over 1, so it becomes 15X over 15 minus the over 5 times by 3, so I get 3X over 15, and the over 3 times by 5, so I get minus 5X over 15. Okay, now I'm going to add these fractions and take these fractions on the right hand side, and I get 7 equals 7X over 15. I can see that I can divide both sides by 7. 1 equals X over 15, and I'm going to times by 15. 15 equals X. So I was asked how many puzzles I brought, and I said that my total number of puzzles was X. There. So I now need to just state in words that I have found my answer. So how many puzzles did I bring with me? I had 15 puzzles. Done.